Yeah, they moved.
Oh, now it's gone. Okay.
Hey,
Given the which is side B. Let's look at side B. Let's calculate the value of B. Now, if you remember in Pythagoras, our B there will be the hypotenuse side. And of course, the other two sides are given as 24 meters and 700 centimeters, respectively. Now, what we need to do here is to carry on to convert. Let us convert 700 centimeters and convert it to meters. Remember that when you convert anything, or when you convert centimeters to meters, always divide by 100. So we are going to divide here by 100, which is the 700 there. We're just going to divide that by 100. And of course, 700 divided by 100 will give us 7 there. So it means that 700 centimeters will be equal to 7 meters. And of course, you've got 7 meters there, you've got 24 meters. So to find B, remember that B is the hypotenuse side. So all that you need to do is to now calculate B squared is equal to 24 squared plus 7 squared. And of course, this is how we calculate it. First things first, we have now converted the 7 centimeters to 7 meters by dividing by 100. And of course, as you can see, B squared will be equal to 24 squared plus 7 squared. Of course, the next one there will be b squared is equal to 576 plus 49, which is 729, because 24 squared gives you 576, and 7 squared gives you 49. Of course, this becomes b is equal to the square root of 625, and of course, the square root of 625 is 25. So the value of b will be definitely be 25. So that is the value of b, and we can just come to look at the next activity there. Right. The next activity, we are carrying on now with the next one, which is the FDE. So in this triangle here, what is important is to remember that you are given now the hypotenuse side. You are not given F, which is just the adjacent side there. And you are given FD. But then again, you can be able to see that the side FD is given in millimeters, whereas the side FE is given in centimeters. So you can see that FE is equal to 41 centimeters, whereas FD is 90 millimeters. So we need to convert one of these. And I always say that in mathematics, the best way to solve any mathematical problem is to ensure that you work with smaller numbers. That is why it will be easier for you to convert the 90 millimeters to centimeters, because then it will give us a smaller number there. Unlike converting the 41 to millimeters. Remember, when you convert from centimeters to millimeters, you multiply by 10. Remember that when you convert from millimeters, you have to divide by 10 when you convert from millimeters to centimeters. And of course, you multiply by 10 if you convert from centimeters to millimeters. Now let's convert. Let's look at the one, how we've converted. Now in the second triangle there, it is clear that when we convert 90 millimeters to 9 centimeters, we are going to divide by 10, as I've said. And if you divide 90 by 10, you get 9. Therefore, 9 millimeters will be equal to 9 centimeters. And of course, you will be able to then equate your 41 squared. Remember that 41 is your hypotenuse side. That is the longest side, rather called the hypotenuse. So if you can see there, we have got 41, which is opposite the right angle there. This side, which is opposite the 90 degrees, is known as the hypotenuse side. And always when you square the hypotenuse side is equal to the sum of the squares of the other two sides. And of course, this is how we square it. We have 41 squared is equal to 9 squared plus f squared. And what does this tell us? This tells us that can make f the subject of the formula. By the way, if you make f which is equal to 41 times 41, which is 1,681, minus 9 squared is 81. Remember that when you transpose this 9 squared to the left-hand side, it will become now 41 squared minus 9 squared. So it will change the sign. So basically, that is what we have done. We have managed to change the sign of 9 squared. That is why it is minus 81 there. And of course, if you subtract 81 from 1,681, you will be able to get 1,600. And this, of course, means that to get F, in order for you to get the 1,040, therefore F is equal to 40. So we have now calculated the missing side, which was F, and it's also known as DE, triangle DEF. Now we can go to the next triangle, which is triangle GHI, and find the missing link there. So if you look at triangle GHI here, you can see that you are given two sides. And this is one side GH, and the other side is GI. And of course, the other one is HI, which is G. And if you were to now find the missing side G, you will be able to see that G is not the hypotenuse side. The hypotenuse side there is FR. So the square of the hypotenuse side is always equal to the sum of the squares of the hypotenuse. And this is in a right angle triangle. So basically, if you have looked at that one there, you will be able to see that the square, or rather, the hypotenuse side is 37. It's given us 37, and here is 37 there, 37 millimeters. And of course, this is equal to the sum of these two squares, 35 squared plus G squared. So that's how you find 37 squared is equal to G squared plus 35 squared. It's really up to you. You can start with 35 squared there if you want. You may also start with G squared. But what is key is to transpose. Remember, this is the same as once you transpose this 35 squared to the left-hand side, it becomes negative. Then you have 37 squared minus 35 squared is equal to G squared. So then you can swap them together. You can have G squared on the left-hand side, and then the right-hand side you'll have 37 squared minus F squared. So before we carry on, just to see that G squared will be equal to 37 squared is equal to 1,369 minus 1,225. And this, of course, gives you 144. Now, the square root of 144 is equal to 12. So I'm now going to open the lines just for questions, particularly in regard to what we have already done here, if there are any questions. And in the absence of questions, we can just carry on to determine the value of K, which is found here in triangle JKL. That is the last triangle there. I want somebody who can tell us how are we going to find the small k there, which is in this case at the adjacent side. We have the hypotenuse side here, then use Pythagoras to find the value of k. So can we get someone to tell us how are we going to find k? If I could just see your hands. Let's carry on now. All right, I don't see any hands as of now.
Hello.
Yes.
Can I answer?
Right, go ahead.
Can I please answer?
Hello.
You take.
All right,
You convert.
For the last one now, for the last triangle.
You convert 9,000 to kilometers. So 9,000 becomes 9,000 becomes 9. To take.
Okay, how do you find 9?
You convert.
Sir, he divided 9,000 by 1,000 to give you 1 kilometer. 9 kilometers, I mean.
Exactly, that's what I wanted to know. Thank you very much indeed. You divide 9,000 by 1,000, and then you get 9 kilometers. Now, can you find K now? How are you going to find K? Using Pythagoras.
Mute.
You've correctly divided 9,000 by 1,000 to get 9. So you are correct when you say 9,000 meters is equal to 9 kilometers. So that's the correct answer there. And of course, I want you now to find the missing value of K there. What will be the value of K in kilometers?
You say 15 square minus 9 square. But before you minus everything, you have to square 15. 15 square is 225. And
Okay.
9 square is 81.
All right.
Then you minus, you have to minus 225 minus 81. And that will give you 114 and 44.
Okay, you said 225 minus 144. And how much?
225 minus 81.
Okay, 225 minus 81. How much do you get?
Yes, you get 12.
All right, I think 12 will be the final answer there. But
Yes.
if you minus 81 from 225, how much do you get? You get 144?
44.
144.
Yes.
Yes, and thereafter you introduce the square root. Remember the K squared, it will be K squared. Thereafter you introduce the square root. So definitely you are correct, as you can see. The first point there is to convert your 9,000 meters. So once you convert the 9,000 meters to 9 kilometers, it means you have divided by 1,000. And of course, then 15 squared, as you said, is equal to 9 squared plus K squared. K squared is 15 squared minus 9 squared. And of course, this gives you 225 minus 81. And if you subtract 81 from 225, you will be left with 144. And remember, why do you introduce the square root? Because we had here K squared. So once you have got the square root of K squared, then you'll be left with K. All right. And of course, whatever you do in the left-hand side must be done in the right-hand side. Introduce the square root of 144, which is 12. So yes, definitely, that's correct. Thank you very much indeed. And let's carry on now the next category now. As you can see, we have got 3 or 5, let me rather say 5 different triangles there that we'll be looking at. Triangle ABC, but yes, triangle ABC there, triangle BCD, triangle EFG, then FGH, FHJ. Now we have got 5 triangles, and I want you to determine with reasons the value of A, B, E, G, and H in this diagram using Pythagoras. Why do we use Pythagoras? Because each and every one of these triangles is a right-angled triangle, and there are sides that are given and there are sides that are not given. You've given, like in this case, in triangle ABC, you are given the side AB and AC, but you are not given the side BC, which is a small letter A there, which is our hypotenuse side. Now, I want us to determine these values, but thereafter, we need to show all the necessary calculations in determining the perimeter of quadrilateral ACBD. This entire quadrilateral, this quad, 4-sided figure, ACDB. Yes, you can start by saying ACDB if you name your quadrilateral there. And of course, you must find the perimeter of this quad. You must also find the area of this quad. Then the perimeter of this polygon here, EFJHG. It's a five-sided figure there. I'm sure you can see EFJHG, this five-sided polygon. And of course, the next one will be the area of that polygon, the five-sided figure there. All right. Now let's start with the first one. Determine the value of A, and then we'll come to B, E, G, and H in these diagrams above. Let's start with the value of A. So you can see that A is the hypotenuse side. Who can tell me how are we going to find this value of A? What will be our formula to find A? Ashley Mavungu, can you tell me how are we going to find the value of A in this triangle ABC, but the unknown value there, which is A? How are we going to find this particular value of A? Right, to find A, obviously, you can see that A is the hypotenuse side, so therefore A squared is equal to 12 squared plus 9 squared. That's how we go squared plus 9 squared. And of course, 12 squared is the same as 12 multiplied by 12, which is 144. And 9 squared will be 9 times 9, which is 81. And thereafter you add the two, 144 and 81, as follows. Now we have got A squared is equal to 9 squared plus 12 squared. Then you add them together there. And of course, 81 plus 144 gives you 225. 225, if you want the square root there, the square root of 225 will give you 15. I hope that it makes sense, that the square root of 225 will give you 15. So meaning that this value here, the value of A here will be 15. So remember, it is very important, let me tell you up front, it's very important that you find the correct value here. If the value of A is not correct, the value of B will also not be correct. The B value there depends on A, on the correct value of A. Once you calculate the correct value of A there, it must be correct. So right now we've correctly said that the value of A is 15. So we are now going to 15, which will be here now. Let's use the value of A there, and the hypotenuse side is 39. Let us find now. Let's find B. Can we find B? Is there anyone who wants to try and find B for us? Using this side, the hypotenuse side, 9, and this value. Now we've got 15, we have 39, we have the unknown there, which is B. Can we find? Let's find B. Let us find B. Now to find B, obviously you need to use Pythagoras again. So you use B squared. In this case, B squared will be equal to 39 squared minus 15 squared. That's how you will find your B. Remember, 39 is your hypotenuse side. So you have to 39 squared minus 15 squared. So this is what we have in triangle BCD there. B squared will be equal to 39 squared minus 15 squared. Remember that your 39 is the hypotenuse side. And of course, if 39 is hypotenuse, then you square it, then you subtract 15. And 39 multiplied by 39 gives you 1,521 minus 15 multiplied by 15 gives you 225. And as you can see, when you subtract 225 from 1,521, you'll get 1,296. And of course, the square root of 1,296 is required in order to find B. Therefore, B will be equal to 36. So if B is 36, found A and B are the correct answers that were found. A and B. A in B is as we have now found 6. I hope that makes sense. I hope that makes sense. Now we have to carry on now to find the value of E here in this triangle. You can see triangle EFG. It's the right angled triangle. We are given the value of EF, which is 24, EG, which is 7. And we are required to find FG, which is the small letter E there. Can we find small letter E? Let's find small letter E there. So you can see that the E there is also the hypotenuse side in triangle EFG, because this side is opposite the right angle. And of course, how would you find it? Again, you use the Pythagoras. E squared will be equal to 7 squared plus 24 squared. And thereafter, you can go on to show 24 squared is equal to 576 plus 7 squared is 49. Now, if you add the two together, you get 625. And of course, the square root of 625 will be 25. That's how we find the value of E there. And remember, just in the same way as A and B there, the value of G and H depends on the correct value of E. In other words, if your E value there is not correct, that is going to affect the value of G and the value of H. So you need to make sure that you find the right value. Because if you miss this value here, you have missed all the values. Because this value, for you to find G, you need to have, you're going to use E. To find H, you'll need to use G. So now we have found E, and we have said that the value of E is 25. I hope that it makes sense. Thereafter, we now have to find G. And as you can see, because E there, we said is 25, sorry, as shown in the previous solution, there is 25. So if E is 25, then let's find G now. Now remember that E is your hypotenuse side. So you have 25 squared is equal to E squared plus G squared. If you want to make G the subject of the formula, you have to say G squared is equal to E squared minus 50. And remember that the value of E, as correctly said, is 25. So meaning that you'll have to say G squared is equal to 25 squared minus 15 squared. And of course, 25 squared minus 15 squared, 25 times 25 gives you 625. And of course, 15 squared by 15 by 15 is 225. Let's go to Ashley now. Ashley Mavungu.
Sir,
Yes.
I wanted to say I'm not understanding this method.
All right. So you're saying you don't understand the method?
Yes, sir.
Okay. All right, let me explain it. or let me rather take you back to the first slide where, okay, do you have a different method maybe before I go to the first slide? Is there any
No.
different method that you understand? Or do you want me to explain?
Please explain this one.
Okay, fine. Let me take you back to the slide where we introduced our Pythagoras. And we said that in this case, when you have got the square on the hypotenuse side, the square of on the hypotenuse side and the squares on the other two sides, if you add, if you equate them, you'll see that c squared will be equal to a squared plus b squared. Now let's focus on this triangle there. The side 5 there, which is opposite angle C, that is small letter c. And this side, which is opposite angle A, it's small letter a. And the other side, which is opposite angle B, is small letter b. Now, we are saying that in any right-angled triangle, c squared, c, which is the hypotenuse side, meaning that the side that is opposite the right angle, if you square that side, this will be equal to the sum of the squares of the other two sides, meaning that in this triangle here, you have c squared is equal to a squared plus b squared. And c, remember, it's 5. That's the side that is opposite angle C. And you'll say 5 squared is equal to A, remember, is 3. It's equal to 3 squared, and B is 4, that is plus 4 squared. Then you'll see that C squared, which is 5 squared, gives you 25. And A squared, which is 3, gives you 9. So 3 squared is 9. And 4 squared is 16. And of course, if you add these two together, they give you 25. This means that c squared is equal to a squared plus b squared. And this can be summed up as the theorem of Pythagoras. The square of the hypotenuse side. You need to remember the key concept here. The hypotenuse side, which is the longest side, the side that is opposite 90 degrees. Now we are going to apply this in a real example. We have already done so in the first case. Like in this case, we had to convert our 700 centimeter. I'm sure you have no problem converting from centimeters to meters. All that you do there, you divide by 100. So of course, 700 divided by 100 gives you 7. So means that BC here will be 7 meters. Now, if BC is 7 meters and 8B is 24, what is the value of B? Now, using the same Pythagoras that we spoke about here, c squared, which is now the hypotenuse side squared, is equal to a squared plus b squared. 5 squared is equal to 3 squared plus 4 squared. Now, even in this case, you are going to say b squared is equal to 24 squared plus 7 squared, as we have done it in the following. And in this case, 24 squared is the same as 24 multiplied by 24. And 7 squared is 7 multiplied by 7. And if you multiply 24 by 24, you get 576. And if you multiply 7 by 7, you get 49. Thereafter, you add the two together to get 625. And once at this point now, remember this is still b squared. So b squared is equal to 625. Now what will be the value of b? Now to get b, you need to introduce now the square root. The square root of b squared gives you b. Perhaps it's important to mention that from previous knowledge. The square root of b squared is b. And whatever you do in the left-hand side must also be done in the right-hand side. So you have the square root of 625, which is 35. So b, the value of b in this particular triangle here will be 25. And of course, you can see that 25 is the longest side because the other sides are 24 and 7, respectively. So this is Pythagoras. I advise that you go back to revise just Pythagoras after this lesson and look at the different sides, the hypotenuse and the other two sides. We were busy with this one now. Yes, we were here now. We had already found G, of course. Yes. The last one is H. Did we find H? I think we did. Let's see. No, we didn't find H. I think we were just finding G here. Yes, we have said that G relies heavily on E. And of course, we found the value of E in the previous slide. And we also found the value of G. The value of E, which is 25. And of course, the next value there was that of G, which is 20. And of course, the last one, which is H, we said that to find H, you need to use G again. And of course, once you use G, you will be able to see that H will be equal to 60 in triangle FHJ. And then the next one, of course, will be this particular triangles where we have to find the value of A. So basically, in this 5 triangles here, we found the missing sides using the Pythagoras theorem. And once you have used Pythagoras, now you can show that all the necessary calculations and determine the perimeter of quadrilateral ACB. So as soon as you have found all the sides, we found B here. Remember, we found the value of B. If I can take you back, what was the value of B? Said that B is equal to 36. And as you can see, since B is 36, then we can find now the whole distance around the edge of this shape, this quad. We call it a quad or a quadrilateral. This quadrilateral here, we can find its distance, meaning that we are starting from A, move to C, point there. From C, you go to D. From D, you go to B. And from B, you come back to A. That is, you shall have completed your race. So basically, you calculate the distance around the edge of the shape. And we have said that the value of B here is 36. Now, how are you going to find, who can tell me what will be the value of this perimeter here, the perimeter of ACDB? Give me the value there of the perimeter. The value of the perimeter. I don't see any hands, actually. On Tatile, all right, I see that there are some few hands. Just don't see which hand is up now. Let's see. Right, let's go to, yes, you can carry on. You did not put your name. Just put a sign. Let's go on. Yes?
96.
96. How did you find 96?
9 plus 36 plus 39 plus 12.
Yes. So 9 plus 36 gives you all right.
40.
9 Yes.
37.
All right, 9 plus 36 plus 39 plus 12. And the total amount is
96.
96 centimeters. Yes,
Yes.
I fully agree with you. It will be 96. That will be the distance around the shape or
Yes.
the edge of the shape. Now, can you tell me, did you find the area as well?
No, not
Or-
yet, sir.
Not yet. Okay,
No,
great.
sir.
All right, so to find the area there, thank you very much indeed. Now, to find the area, you just have to calculate the area of triangle ABC and the area of triangle BCD. So once you find this whole area here in the red triangle,
So,
yes,
so in order to find the hypotenuse, we add the numbers we already have.
in order to find the perimeter, yes, you add all these numbers that you already have. But on the
Okay,
side,
thank you.
on the side, yes. So it will be AC plus CD plus DB plus AB. That will be the perimeter. But to find the area, remember the area of a triangle, the right angle triangle, half a base multiplied by the perpendicular height. Half a base multiplied by the perpendicular height. Remember, this applies in both triangles. Luckily for us, in a right angle triangle, we always have the perpendicular height. Like, let's go to triangle ABC. What is the perpendicular height there? The AB, that is the height of the triangle. And your base is 9. Let's go to triangle BCD. BCD height there is BC and the base is CD. So therefore, you will have half of this, half a base times height of this triangle and half a base times height of the other triangle, then you add them together. But we will probably have enough time tomorrow to look at these different aspects, the area, as well as the perimeter of the entire polygon. We just have to take it from again tomorrow just to finalize. We still have a lot of examples that I should wanted to look at, but for now, I just want to urge you to visit the YouTube, the link that is on the board there, just to have more explanation on Pythagoras. And of course, the next one will be to invite you to the next lesson, where we will continue to solve these problems, calculating the perimeter and the area of polygons. And at some point, we'll also calculate the area of a circle, as well as the perimeter of a circle. But for tomorrow, we'll just do the polygons. And until we meet tomorrow, my number is there on the screen. Please reach us out on a Twitter account at Africa Team Geeks, but also on Facebook, go to Africa Team Geeks. And of course, this work is brought to you in collaboration with the GBE by our sponsors, Sasol Foundation, as well as MS Zora. Thank you very much indeed. Until we meet again tomorrow.